So good morning everyone and welcome to the class on tribology. So as we covered our module 5, we had left out related to dealing about the case study related to selection of the bearing materials. Well, everyone presented well with respect to the topics which were assigned to you all as part of our OBE activity. So now we will be just focusing on the last case study related to our module 5. So in that aspect, let me go through the case study. Okay, so here it is a bulletin which has been newsletter which has been written on bearing materials which are widely used in selection of a particular material for particular type of bearings. So it was an newsletter which was published in the year December 26, 2020. Okay, so here it was like the letter which was drafted by a person, John Valence, who is related to the bearings and manufacturing part. He is the vice president for that particular company. Here they are discussing about the materials, what they are in general in practical using for our bearings. So these are like ceramics, chrome steel, stainless steel, and plastics. So on that, they have just drafted a newsletter related to the which are the type of bearing materials which are frequently in use. So when it comes to the bearing or as a bearing industry, usually they go on using different materials, right? So you need to be very keen in selection of which material is most suitable for the production. It mainly depends upon which is the type of bearing you're going to produce. And also it depends upon the bearing components, what you want to develop. Okay, so based on the requirement, one has to go for the selection of the bearing material. In that aspect, so there are different number of materials which are commonly in use. So those have been discussed here one by one. So we have dealt in our syllabus related to the bearing material, its huge lot of classification, its importance, properties, and which could have a better functional aspect related to the different type of bearings. All those we have studied. But now when you go for the industry point of view, when they want to manufacture the bearing components and assemble and make it a single one, you need like different common class of materials what they are using with the required property and grade. So those we are dealing here one by one. So the first one normally generally used material is the chrome steel. Okay, so it is like in bearings which are made by using the chrome steel. So here the grade which has been assigned is as SAE 52100. So if you come across SAE 52100, so then you should be able to identify this is the chrome steel material which is being used. And now you have to see that this is the most commonly used material. Okay, so this is the most commonly used material in order to produce the ball bearings, roller bearings. Okay, because it will be able to withstand a large amount of load bearing capacity. So whenever you need like the bearing which want to withstand a large amount of load, so it's always better if you go with the chrome steel of grade SAE 52100. Okay, so in that case, in all the type of precision ball bearings, roller bearings, even tapered roller bearings, this chrome steel is most widely used. Okay, so here the components, basically the inner bearing components, the outer rings, the balls and the rollers are most commonly made up of this chrome steel. So when it goes for the chrome steel, you should also think about what is the chemical composition involved in this chrome steel. So you have to see that the chemical composition of the steel will contain like the carbon. So high amount of carbon content, about 1.5%. And apart from that, you will be having the chromium content in it. So these two are the materials which are being used in chemical composition in proper stoichiometric ratio to get the required chrome steel. And also to develop this chrome steel, some type of processing has to be taken care, and heat treatment also should be provided so that you get the required strength, hardness across the surface, and it also helps to resist the rolling contact surface from the fatigue also. So once this chrome steel has been synthesized by using our high carbon and chromium content, you should see that it is subjected to the heat treatment so that it will get the required amount of hardness, and hence it can face across the contact area. And even the subsurface also can resist from that of fatigue, which can happen into picture when you are subjecting continuously to an continuous amount of load. Right, so in this way, this will be very good material for the type of bearings what we discussed about, like the ball or roller bearings. Okay, so when you develop the components using this, what we say, the chrome steel, so usually, and when it is subjected to heat treatment, usually the surface hardness of the bearing components will be ranging in between 60 to 64. Okay, so this was tested by using the Rockwell hardness machine. Right, so when you have this class of material for making the bearing components, and you can keep in mind that the hardness what you're getting will be in the range of 60 to 64. So this is the minimum required specifications one has to know thoroughly when if you are going for chrome steel. So when you think about the chrome steel, you should tell why you are selecting that, because when if you need any bearing to withstand large amount of load, so it's better to go with the chrome steel. So that is what you have to mainly understand. And apart from this, you have like in-depth classification also if related to chrome steel. So one more is extra clean chrome steel, it is called. It is also like the same grade 52100, but it is called as an extra clean. Okay, because you'll be subjecting to more heat treatment process and getting more raw steels which are required for better accuracy and precision values in the required things. So here you can see that you will be using a raw steel. Okay, so this raw steel will be produced by high precision miniature bearings. So here the steel what you're using will be the raw steel, and the required processing will be developed with respect to the melting steps. So you'll be having one or the other, more than one melting steps in order to get the required additional properties to the raw steel. So the type of the steel what you get will be uniform, and the grain material will be homogeneous. So if you go and subject to an micrograph, you can see the homogeneity in the grains of the steel what you have developed. And hence you will be having a super finished and very smoothness across the surface. Right, if you go for the extra clean 52100, mainly you will get a smooth finish. Okay, so this is why, because it will be like an uniformly grained material of the steel, so that you can cross check if you go into the micrograph. So that will tell you whether it is an homogeneous mixture developed or not. So if that is the case, obviously you'll be having a uniform fine grain of the material. So even here, it has to be subjected to the heat treatment. It is not like you won't do, you will subject to the heat treatment in the open atmosphere, and the required hardness of the steel will be developed. And if you go with the chrome steel, so like the temperature what you can bear is nearly up to 120. I'm sorry. It is 120 degrees Celsius what it can operate. So this is the upper limit. Suppose if you want to operate the same bearing of the chrome steel to the higher temperatures, so what you have to do, you should be having an stability for the heat, right? So the heat withstanding capability of the bearing component should be made. So for that, what you have to do, you have to enhance the heat treatment process, and you have to see that you will make these chrome steel withstandable to the higher operating temperature. So if you provide a better heat treatment process for a longer duration of time, so then you can enhance the operating temperature of these bearing materials nearly to 220 degrees Celsius. Regularly, normally with a normal heat treatment process, it can go until 120. If you want for some specific high temperature applications, then you have to think and you have to modify the heat treatment process in such a way that it is capable to withstand a little higher temperature, nearly equal to 220 degrees Celsius. Okay, so this is how you will figure out the existing material to the normal heat treatment. And if you want to use this for elevated high temperature applications, then you have to think about how to optimize the annealing treatment, the heat treatment process, or improving the density of it by subjecting to sintering or any calcination parameters, so that it helps in getting the required operating temperature of 220 degrees Celsius. So wherein even in the elevated temperature, the material will be able to have a good hardness of the material and to maintain a high amount of load carrying capacity. But when it goes, this will substantiate when it is at 120. But when it goes for a very high elevated temperature, what happens is it is clearly mentioned that the load carrying capacity of the bearing is reduced slightly. Why? Because it has very high temperature. You take any material, the property of the material at room temperature will be different. So when it goes for the higher temperature and elevated temperature, the property of it will slightly reduce because it is going at a high temperature. In the same way, even at the elevated temperature, the load carrying capacity of these bearings will be reduced. Okay, so this is the thing which they have concluded. And here you can see the combination of the various grades of chromium steel. So before that, you can see that SAE 52100 is also an excellent general purpose bearing steel. So whenever you want to go for a general bearing system, so this SAE 52100, what we studied, the chrome steel right now, is a general purpose type of bearing steel which has been widely used. Okay, so why it is widely used? Because it has excellent hardness and it also have a good amount of wear resistance, right? And apart from that, I told you that it exhibits a good fatigue life, mainly in rolling element bearing. And due to these reasons, this is the most commonly used. Apart from that, it has resistance for corrosion also, but not to an higher extent. Okay, so it is one of the little part of drawback. Why it is not so resistant to corrosion? Because it has a chromium content in it and not to a very high value. It is of small percentage of chromium content. What does it have? And as a result, the corrosion resistance of these material will be not too good. But it has an excellent hardness as well as the wear resistant property and good load bearing capacity. So due to these three characters, this SAE 52100 is an excellent material which has been used for bearing for general purpose applications. So if we go with the chromium steel, so you can see like different stoichiometric composition of different chemical components with respect to different grades. Okay, so the same chromium steel, chrome steel in USA, it is termed to be as AISI 52100. So here the carbon content is like around 0.95 to 1.1%. Silicon content is 0.15 to 0.35. Manganese is of 0.5. This is the maximum that they can opt for. Phosphorus, it is of 0.012. Chromium, the main composition here is carbon and the chromium, and the rest all are comparatively lesser. Okay, since the chromium content is comparatively lesser, it will not be having a good resistance for the corrosion. Okay, apart from that, you have molybdenum and nickel and also sulfur to a small extent. Similarly, this chrome steel in Germany, it is represented again by a code which is generalized throughout this country. Okay, so if you go for 100 CR6 in Germany, it is the chrome steel what you are opting for. Similarly, if you go for AISI 5210, so this is the chrome steel what you are opting with the same amount of specifications, specifically for the country USA. So here also it is almost the same. Only thing the manganese is varying here from 0.25 to 0.45. And this is a phosphorus content. Chromium content is almost the same. Only it is varying in the second digit. Okay, so molybdenum is of 0.1%. And here they doesn't have any nickel content in it. Okay, so nickel content is absent and they have a sulfur content of 0.2. Similarly, you have the composition for the chrome steel in Japan as well as in China, which has been graded as SUJ2 and GCR15. So you can see the specification, the chemical composition of all the components which are being used. So this is like the stoichiometric composition of every individual element which are clubbed together into a single chemical, which is nothing but our chrome steel. So this is one class of bearing material which is used very commonly in almost all the bearing industries across the world. Only thing is represented with different designations. So next you have stainless steels, the bearings which are made up of stainless steels. In that also you have different classifications. So one is martensitic stainless steel. Okay, so here it is represented by AISI 440C. And similarly, you have other class of martensitic stainless steel, which is represented in different versions. So it is either if you go for ACD 34, yeah, KS 440, yeah, X65, chromium 13. So then also it is the same grade what you will be opting. So if it is across the 400 series in stainless steel, then you can consider that the carbon content in 400 series of stainless steel is comparatively higher. Since it is higher, it can be used for hardening. So you will do the hardening basically when you need a heat treatment process, right? And hence you can get an hardness value nearly to 58. Okay, so in regular without heat treatment, the hardness of the stainless steel will be comparatively lower. And as a result, the load carrying capacity is 20% lower in bearings which are made by this material. If you are opting for chrome steel, you will be having still comparatively better load bearing capacity. But if you go for stainless steel in 400 series, okay, it can achieve the hardness up to 58, not more than that. Due to this lower hardness, comparatively the load bearing capacity will be 20% below than that of the chrome steel what we discussed. So this is in comparison to 52100 chrome steel. So that I told you already. Okay, so the mainly if you go with the content of carbon, it means that components are more magnetic. So when it is more magnetic, how will be the performance of the bearing? So that you have to think of. And in this case, the corrosion resistance is comparatively good than that of the chrome steel bearing. So this is one plus point what you have. So if your main focus is to protect the bearing from the corrosion, so then you can go with this 400 series stainless steel. But the main intention is to bear a high loading capacity value, right? So then it is purposefully you have to go for the other class what we discussed, which is chrome steel, 52100 chrome steel. So based on the requirement, you should be able to select which material you need basically. So these are like the different class of materials which are available. So similarly, you have other class of martensitic stainless steel of different versions, and it is named by different names. Even though it is named by different names, the main chemical composition remains the same. Okay, so in general, you can call this as AISI 440C because it is a stainless steel material which has slightly low carbon content and chromium content, than that of AISI 440C. So this is AISI 440C. Okay, the same composition you have, only the difference is it has small lesser composition of carbon and chromium in comparison to this. And due to this, you have small variation in the carbon and chromium content. These are known by several other names across different countries. So this is ACD34, KS440, X65, CR13. But if you put forward for high heat treatment process, so then you can go for having the good properties for these bearings, so wherein it will help you to get the same value of the corrosion resistance. I told you that this previous composition of martensitic stainless steel had good corrosion resistance in comparison to 52100 chrome steel bearings. But the next version of martensitic stainless steel, what we are speaking here, has less content of little bit less content of carbon and chromium. But still, if you subject for heat treatment process, it is claimed that you can get the same corrosion resistance as you got in 400 series of stainless steel. So this is what it has been claimed enough. And you can go through this. And it also has superior low noise characteristics. Okay, so it is not a very noisy kind of thing. So it has a reduced noise reduction here. And the hardness what you get in this class is nearly to 60. In previous one it was 58. So here in this new version you can see that the hardness due to the heat treatment can go until 60. And even this is one of the widely used material for ball bearings. So whenever you want to go for ball bearings, you can either go with the martensitic stainless steel of any 400 series. Okay, so in both the case, you will be having a almost required amount of corrosion resistant and the hardness value. There is not a huge change. Here the hardness value is 60 and above it was 58. A small variation in the hardness value and an improved version of corrosion resistance will provide you a better option to go with stainless steel for ball bearings. Okay, so this is one of the important characteristics what you have to know. And similarly, you have one more martensitic stainless steel of grade SV30. So again, this has been processed from our raw steel. So how it is processed from raw steel? It is done by lowering the carbon content. So in this martensite stainless steel, the carbon content is reduced. But apart from that, they are introducing the content of nitrogen and its alloying element to it. By reducing the carbon content, they are adding nitrogen as an active element along with its alloying, which are most comfortable with nitrogen composition. So what happens is when you have the nitrogen content in it, the nitrogen increases the saturation of the chromium. Anyhow, along with the carbon, you have chromium content in any type of material basically. So in that you're reducing the carbon content and you're adding the nitrogen content to it. So when you add on nitrogen to it, what happens is it enables the saturation of the chromium. So due to the saturation of the chromium content, what will it do? It will transform into chromium nitrates. So previously it was only chromium. Due to the involvement of the nitrogen content, the chromium gets changed into chromium nitrates. Or else it would have changed to chromium carbides. Why it will change to chromium carbides when it is subjected to heat treatment? Because previously it had only carbon and chromium. So it used to change into chromium carbides when it is subjected to heat treatment. But now, due to introduction of nitrogen, instead of changing to chromium carbide, it gets changed to chromium nitrates. So due to the formation of chromium nitrates, what you will achieve is it results in high strength mainly in comparison to other martensitic stainless steel. Apart from that, it will help you to get high hardness steel. Okay, so this will help you to extend the fatigue life. nearly to double the value, means 100%. So this is the achievement you get by just adding a small composition of nitrogen as an alloying element. So this good amount of high strength, high hardness steel and good fatigue life extension will focus it for various applications. Okay, and also this chromium nitrates also will help you to offer a good corrosion resistance, and this corrosion resistance is comparatively better than both the class of martensite steel. So one is AISI 440, another one is ACD 34. So the corrosion resistance of SV30 is comparatively better than that of ACD 34 and AISI 440C. So this is how you have to analyze. So based on your requirement, you should be able to select the required class of material. I hope you're understanding the different materials which are very commonly in use. Are you people there?
Yes, ma'am.
Okay. So this is the most commonly used materials, and I think there are, yeah, this is done. So when you speak about steel, often it will be not hardened. So it will be in soft state, right? So the heat treatment of the bearing steels is very much essential. So always the bearing materials which are soft, in the sense which are unhardened, has to be subjected to the heat treatment so that it helps to improve, yeah, enhance the hardening capability of that particular bearing steel. So these are usually done by metallurgist person. So they first analyze what is the structure of the steel, what they are taking, how soft it is, what is the actual hardness value, and what is the required hardness value. As per that, how the heat treatment process has to be taken care of, right? So whether it requires a rapid cooling or not, how about the heating rate, what you subject, which is the type of furnace you need to use, which is a melting point of the steel, you have to know exactly so that you can subject it into heat treatment below that melting point, and also that melting point temperature and the heat treatment furnace what you're using, you should check what is the capability of that particular heat treatment furnace. Suppose you want to go like for 1800 degrees Celsius heat treatment, and if you're opting for heat treatment furnace of temperature which is capable of increasing only to 1750, then it will not satisfy your need. So you should think what is your requirement. Accordingly, you have to check which is the furnace you are going to use, and also you have to check what is the melting point of the material for which you are going for heat treatment, so that the heat treatment value should be below its melting point. And all these things you have to understand. And when a heat treatment process will takes place, you know that when you come into steel, a phase transformation occurs. So it changes from perlite to that of austenite phase when the treatment of heat enhancement has been taking place. Okay, suppose if we go even austenite to martensite, it can go. So it will be in austenite at room martensite phase when it is at room temperature. So once it is subjected to high heat treatment, then it goes for the austenite. So this is like the phase transformation which occurs across the structure of the steel when it is spoken with respect to a metallurgical person. Usually, the metallurgical person speaks with respect to the structure of the material and the phase transformation which is happening, and what about the crystal structure, the lattice or structure. So, all those things will happen when you subject for the heat treatment. Okay, since it changes the phase from austenite to martensite, it is usually called as a quenching process. Okay, and the phenomena in which the amount of content has been retained, like from it will be in martensite and it goes to austenite. And when the temperature is removed, the austenite has to come back to its martensite. So when it comes back to its martensite phase, some amount of austenite will be retained in it. Okay, so the amount of austenite which is retained is called as retained austenite. So all these things has to be taken care when you do for heat treatment. In the selection of the material, I just told heat treatment, but this heat treatment also has a rigorous process as one has to follow. They have to analyze the structure, the changes in the microstructure, what is happening, and how the phase transformation is happening. All these things will be taken care in depth until you get the required hardness for that particular steel. Okay, so then you can use that steel for our bearing components. So this is how you have to check the possibilities. Okay, so you will subject for heat treatment and it will be soaked for that particular temperature for some period of time, the dwell time suppose, and then it has to be cooled down. What is the cooling rate you're providing? What is the heating rate you're providing? Is it the proper one, or the rate what you're giving is higher, yeah, lower? So that you won't be knowing in the beginning. So by trial and error, you'll come to know how you can optimize the heating rate and the cooling rate when you subject for a specific heat treatment. So then you'll come to know the loading and unloading, and then how the phase is been changing from austenite to martensite, from martenite to austenite. What is the retained amount of austenite content in it? Everything can be dealt. So this is about the heat treatment of bearing material. And similarly, you have other class of materials. So it is very simple. These things I have dealt in the class also. Carbon alloy steel I have taken care in the class. Okay, the same thing, you can, low carbon alloy steel is there. And apart from that, bearings could also be made up of plastics and non-metallic materials. Okay, if it is made up of plastic materials, we call that as bearing cages, so that you should be knowing aware. Okay, so we usually speak about metallic materials, but sometimes it could be also be done by plastic materials and also non-metallic materials. So you should be able to know. If it is done by plastic, it is sometimes called as to be the bearing cages. So the most common which has been used is nylon. So I have dealt about the bearing materials even for non-metallic also. In that we have dealt about the properties and everything. But here the proper names are being provided to it. So if you somewhere come across in the case study as cages, remember that it are made up of plastic materials. Okay, so one more they do call it as these cages. Okay, the from plastic materials. And one more is the most common seal material which has been used is nitrile rubber, yeah, buna rubber. Okay, so this nitrile or buna rubber which is used as seals has good mechanical properties, and that could be used for wide range of temperature, and it has a good resistance to many chemicals in which it comes in contact, and it is comparatively low in cost. So these are the very good points of this material, the nitrile rubber or the buna rubber. Okay, so this is the most commonly used type of seals in any kind of bearings. Okay, so this has good amount of properties, good mechanical properties. It can be used for high temperature, and it can show resistance to many chemicals in which it comes into picture with the contact. Okay, and then it has a low cost. So these are very good things what one can use it for a unique property. So this I am just stressing you, so you should be aware of the term cages and seals as well. And apart from that, bearings could be done by the ceramics also. So that we have discussed in the class, the properties of non-metallic materials for bearing. So ceramic is one more different area of class of materials, so which could be used. So whenever you want to go for making an hybrid bearing, so it will be better if you go with ceramic material. So here it will be having a combination of stainless steel rings and ceramic balls. Since it has a combination of both metallic and non-metallic material, it is called as an hybrid bearing. Okay, so the most common ceramic material used is our silicon nitrate. This is the most commonly used silicon nitride material for our bearing. So here the balls will be made up of the materials which are harder than that of the value 78. So until now we had come across only 60 as the highest hardness number. So here when you go for hybrid one, you can see that you can get until a value of 78. Okay, and apart from that, it will be having a very smooth surface. But one of the drawback is the hybrid bearings will be little more expensive than that of the stainless steel bearing. So if you can afford the price, I opt that this is the better way to go in, as it has a good hardness value of 78. Mainly the hardness plays a vital role, and even the surface is very smooth. So this grade of bearing material will be comparatively better if the expensive part could be taken care. So this author, John Valence, who is the vice president for this AST bearings company, so it is an ISO graded one. He has took the overview of all the available class of materials, how its properties could be enhanced for different type of development of the bearings, right? So this just provides you an insight like which are the class of materials which are there already in the market, which is being used across the country in different grades, as I mentioned you, right? Even though the content of all these elements are almost the same. So this things related to the overview of the bearing class of materials which are used outside. Also you should be aware enough, we have studied as per our book syllabus, right? So this is the actual class of materials related to the content what we have studied, so that's you should be knowing. I hope the things here are clear enough related to the bearing materials case study, sorry, a news bulletin on it. Hello.
Yes, ma'am. Yes, ma'am.
Yeah, so now I just share only one more sheet for you to make understand. Is the screen visible?
Yes, ma'am.
Yeah. Suppose if they give you the specifications, suppose you have purchased some bearing or its components, and they give you the details of the bearing materials, basically which are needed. So you have to come to know regarding the cage material as well as the material which has been used to develop our bearing components. So the main thing when you want to go for selecting a bearing material, it should have some key material characteristics, right? Either you can be going for rolling bearing, okay, so roller bearing. So what are the main characteristics which has been needed for bearing rings and the rolling elements? You should see that it should have high rolling contact, right? A good fatigue strength, high hardness, high wear resistant. It should have high dimensional stability and also high mechanical strength. So these are the important characteristics what the material has to bear. Okay, in that these three will be focusing on the cage material, right? So you have to check whether the satisfaction is there related to the material what you are selecting. And to check this, the bearing rings and the rolling elements, what you procured, right, will be tested for many repetitive high pressure. Okay, to see that whether it slides properly or it is a small amount of sliding which has been taking place. And when the cages are also being subjected for tension and compression, to see that the sliding contact with the rolling element is proper or not. So with that also you should analyze. So two things is to see the rolling components, how good it is, okay, and also the main characteristics which is needed is satisfied or not. So before we take these materials into hand or the rolling components into hand, so necessary testing will be done. Okay, so when after testing only they'll figure out what are its properties. Right, so if you're going with high carbon chromium bearing steel, so the major elements in it will be given in the specification details. So it could be represented by ASTM A295 or JISG 4805. So this will be the symbol for representation. We studied this one in our case study 52100. Apart from that, you have three more standards which are being available. So everything will be having the carbon content and the chromium content as the major part. Other components will be having slighter values. Okay, so this we have dealt already in the previous case study. Similarly, if you need carburizing bearing steels, okay, so here this will be the chemical composition. So when you go through this chemical composition table, you will come to know which to select and which not to select. If you have low chromium content in it, so then the corrosion resistance will be lesser. If you have high chromium content in it, then the corrosion resistance will be higher. So that you have to understand whether it is making chromium carbide or chromium nitride. If you are adding nitrogen into it, then it results in making chromium nitride, and as a result the corrosion resistance will be little bit lesser. So by looking into the table and the specification detail, you should be having enough knowledge to select which type of bearing material you need. What is your requirement? Whether your requirement is to have an high loading bearing capacity or low loading bearing capacity. So based on that, you should be able to select the bearing elements. And suppose if you want to use this bearing elements for high temperature, then you have a specific grade of material. Okay, so here the standard which has been used is AISI. Again, it is represented by the symbol M50. So this is the composition, the chemical composition, what you have in high speed steel. So wherever you come across high speed steel, so this could be used at high temperature. If that is the case, you have to go with this grade AISI. So this will be the chemical content of it. So you can see what is the range of chemical content you are having. So you have carbon, silicon, magnesium, phosphorus, sulfur, chromium, right? And other components. So this is about the other set of chemical compositions what we have, right? So next table, so 13.2, basically what we studied is for carburizing bearing element, and third one is for high speed. And suppose if you want for chemical composition of stainless steel for rolling bearing elements, so these are the major elements which are available. So in that we have two standards. Okay, so based on the requirement, you will go through the table and select. So that thing you have to keep in mind. And for the cages, okay, we have two tables separate for the cages. One is the chemical composition of of steel sheet and carbon steel. So we need steel sheet and carbon steel for cages, for major elements basically. So in that we have four classes here. So under steel sheet and strip for pressed cages, we have three versions, and under carbon steel for machined cages, we have only one versions. Okay, so these are the chemical composition what it has. It will be having carbon, silicon, manganese, phosphorus and sulfur. Okay, so they are getting this with respect to BAS. It is a Japanese Bearing Association standard. So across the world, it is named with different standards, and some standards are universally recognized and some standards are recognized specifically to their countries. So based on the requirement, you have to see and select. And you have one more for cages, which is chemical composition of high strength brass. So this is the high strength brass for machine cages applications what you will be using. So in that you have again two versions. Okay, so here these are the chemical compositions what one will be using. So it is copper, zinc, manganese, iron, aluminium. and other lead and silicon as well. So here lead and silicon will be used as an impurities. So we'll be adding this as an impurities, means these are like dopants. So which will be like an active members in order to enhance some specific physical properties. But when it is added as a dopant also, since it is an artificial element, what you're adding into the chemical stoichiometric composition which is developed already, it will be termed to be as impurities. So this you have to understand. So these are about the huge class of bearing materials which are available in across many countries of the world in general, which are standardized, and how people will enhance the hardness of the material of the same when it is at normal temperature and when it is at higher temperature. So if it is at normal temperature, it will be a soft material with reduced hardness. If you subject it to heat treatment, then the hardness increases. If you want still for elevated temperature, then the optimization of the heat treatment process has to be taken care so that it helps the same material to work at elevated temperature, but the hardness value will not be so good as the hardness what you used to get at the normal temperature, but still it can withstand. And even the load bearing capacity will not be comparatively very higher, but it will be almost within the range which you need to get. So this is about the in general a bulletin on bearing materials what we discussed in today's class. So this will hold good as a supporting document for the module 5 what we have discussed in last to last class. So any doubts associated with this? Hello.
No.
So hope the things are clear. If that is the case, everyone kindly type your name and USN in the chat room. I will call your attendance one by one. Just 26. Akhil KV,
Yes, ma'am.
Anil Kumar. Anil Kumar is absent. Ankesh Aman. Ankesh. Gautam Krishna.
Yes, ma'am.
Okay. Balaji VR. Balaji is absent. Beldar Mohammed.
Yes, ma'am.
Chaitanya.
Present, ma'am.
Chetan Kumar. Chetan absent. Dheeraj.
Yes, ma'am.
Ishant.
Yes, ma'am.
Harshit. Harshit. Okay. Himanka.
Present, ma'am.
Kanishka. Absent. Nagamurli Krishna. Absent. Kunal Raj. Dhanush is not there. Mohammedayan. When he is absent. Mohammad Junaid. Sri Prasad. Absent. Niharika.
Present, mom.
Nihar Venkat Sai. Nihar. Absent. Nikhil. Nirav.
Yes, ma'am.
Okay. Prajwal.
Present, ma'am.
Okay. B1 batch, we will meet by 10:50 a.m. Everyone kindly be there for SimLab. Rishabh,
Present, ma'am.
Rohan, Rohan Kaglakar absent. Roshan Yadav. Okay. Sumant, Sumant Sagar, Sagar Dutt Mathur,
Yes, ma'am.
Sagar GV,
Present, ma'am.
Sanjay Raghav, absent. Shobit,
Present, ma'am.
Siddharth, absent. Siddharth Sridhar, Subramanya,
Present, ma'am.
Tirumana Sethi Rohan.
Yes, ma'am.
Okay. Ullas,
Present, ma'am.
Vidyan, Vidyan is absent. Varun, absent. Pawan, Not there. Danush?
Ma'am,
Present?
present, ma'am.
Okay. Dhyanesh Kumar? Absent. Gunasagar? Absent. Meghanatha? Rasik Baran? Shiva Krishna? I think Shiva Krishna is present. Shreyas? Yeah. Shreyas? Shreyas is absent. Srinivasalu? Yogananda?
Present, ma'am.
Okay. Kiran? Kiran is absent. Ranvir Singh? Absent. Gautam Sai? Abdul Khalid Pasha? Shiv Pavan? Alok? Fine then, everyone take care. Have a nice day. Good day.